All right, open up your book to section 4-2. We're on page 178 in your book, and the title of this section is Quadratic Functions, Factoring, and Complex Numbers. The objective for this section is to review the properties, graphs, and techniques associated with quadratic functions. So we've talked about quadratic functions actually in the previous two chapters, and we're going to continue with that discussion here, but hopefully we'll find that some of these techniques we're going to talk about here are a review, as it indicates there in the objective. All right, let's talk about zeros versus x-intercepts. Sometimes these two terms are used interchangeably. In fact, I find myself guilty of doing that as well. But there is a difference between the two, and we should distinguish between the two here. A zero of a function is any real or non-real, that is, it's complex, any real or non-real value of x that makes y equal to 0. So that's what a zero of a function, and it doesn't matter whether you're talking about a quadratic function here or any other function that's referring to any function. Finding the zero of that function means you're finding any real and non-real value of x that makes y equal to 0. On the other hand, the x-intercepts of a function are a point that's a real value where the function intersects the x-axis. That's also then where the function is equal to 0, but realize that these are the real values that we're talking about, not the non-real or complex values. So one thing to note here about quadratic functions in particular, since that's what this section's about, every quadratic function has exactly two zeros then. Turns out that you will have two zeros. You're guaranteed of that, whether they are real or non-real. But you may have either 0, 1, or 2 x-intercepts. So again, there's a difference here between the zeros of the function and the x-intercepts of that function. Guaranteed to have exactly two zeros, but you may not have two x-intercepts. When we look at a quadratic expression, there's actually several ways that you can write that quadratic expression. This first form is what we call the polynomial form. It's probably the one that we're most familiar with when we work with a quadratic function. We say y is equal to ax squared plus bx plus c. But for any quadratic expression, we call that the polynomial form. If you remember that general form of a polynomial, we'll talk about that later in this chapter, but that general form of that polynomial, that long equation there, a sub n x to the nth plus a sub n minus 1 x to the n minus 1 and so forth, that form there is the form you're looking at here, and that's why it's called the polynomial form, ax squared plus bx plus c. The second form is the factored form. This is a very helpful form if we're trying to find the zeros, for example, of a quadratic function. Then getting it into the factored form is really nice. And the factored form would be a times x minus z1 times x minus z2, where z1 and z2 are the zeros. Again, those are zeros, so that means they could be real or non-real. But that's the factored form. You factor out the a out front, and the a in this form and the a in the polynomial form are the same number. But obviously the z1 and z2 are not the same as the b and the c up above in the polynomial form. And the last form is what we call the vertex form. And the vertex form, we've actually seen that before when we were talking about quadratic functions back a couple of chapters, and we looked at the transformed equation. This is what we had written down. This is also known as the vertex form of a quadratic expression. A times the quantity x minus h squared plus k. And it's called the vertex form because the hk that is listed there is the location of the vertex. That's that lowest point on a quadratic function that's concave up, or the highest point for a quadratic function that's concave down. One thing to note here, again, trying to connect these forms and just make sure we're clear on what's what. The a value, first of all, is the same a value in all three of these. But this h value that we're talking about here can actually be calculated from that polynomial form. It turns out it's the opposite of b over 2a. If you calculate that, that'll be the x location, the horizontal location of your vertex. All right, take a look at example 1 here on page 178. It says to multiply the binomials and simplify. So a little bit of revisiting of some algebra here is really what we're taking a look at. So let's write down these two binomials. We're given 3x plus 5 and 2x minus 11. And they just want us to multiply these out. So again, the technique that you use here is usually referred to as the foiling technique, although there are a number of different techniques. Some people will draw a lattice and do it that way, or a grid and draw it out that way. I'm going to just simply use the FOIL method here as the way that I'm going to do that. FOIL stands for the F is for first. So that's what we're going to multiply together, the first terms in each one of these. So it's going to be 3x times 2x. The O stands for the outside, so that's the outside two values here. So I'm going to add that to 3x, and the negative 11 is what we're going to multiply together. The I is for the inside, so looking at the four terms that we have here, the two inside terms are the 5 and the 2x, so we'll add that to the 5 times the 2x. And then finally, the L stands for last. So in each set of brackets, parentheses there, we'll just multiply our last values together. That's the 5 and the negative 11. All right, that's the FOIL method. And now simplify this. You have 3x times 2x, that's 6x squared. You've actually got two x terms here in the middle here. We'll combine those here in a second, but let's multiply them first. We've got 3x times a negative 11, that's a minus 33x. You've got 5 times 2x, that's 10x. Again, we'll combine those in just a second. And then 5 times the negative 11 would be a minus 55. And then finally, since these are both alike, they both have just an x, I can combine those and determine how many x's total I have there. So negative 33x plus 10x will give you a minus 23x, and then the minus 55 at the end. So there's that binomial multiplied together. All right, again, hopefully that's just a quick refresher of some algebra we should know by now of how to take two binomials and multiply them together. Take a look at example 2. For example 2, it says multiply the binomials and simplify. So we've got x minus 5. We've got three terms here, or three factors now here, I'm sorry, for us to deal with. So it's x minus 5 times x minus 2 times x minus 1. And we want to multiply those together. So to multiply those together, you have to associate two of these. It doesn't matter whether you pick the first two or the last two to associate. Or I guess for that matter, you could pick the first and last factors to associate. I'd probably pick the first two together myself just because I think of working from left to right. But you could pick any two to multiply together first. This is the associative property that works for algebra, for multiplication in algebra. So if we multiply those together, I'm going to go through and multiply these a little bit faster this time than what we did on the previous example there. But if I take x times x, I'll get x squared. If I take the x times a negative 2x, or times a negative 2, that'll be a minus 2x. And then negative 5 times x, that's another negative 5x. So that's a total of a negative 7x. If you need to write those down separately and then add those together in a separate step, then do so. But hopefully we get ourselves to a point where we're comfortable doing that. And then finally, plus 10. And then we still have to multiply this by the x minus 1. So now when we multiply this through here, I'm going to take that first term and distribute it through the second factor there. So I've got x times x is an x cubed. You'll have an x squared times a minus 1. That'll be a minus x squared. Now technically there will be some terms I can combine here, but I'm going to keep them separate for right now. And now move on to the negative 7x. The negative 7x gets multiplied by the x, so that gives me a minus 7x squared. I'm going to just write that down below there so I can see that I can combine those two. And then I have the negative 7x times the negative 1. That's a plus 7x. And then finally multiply the last term there, the 10, through the parentheses, and we'll have a 10x. I'll put that down below the 7x that I have here. And the 10 times the negative 1, that'll be a minus 10. I've just written it this way just so you can see that we can kind of add this up. And I've already kind of aligned things here to add it up. You certainly don't have to write it out this way. You can write it all out in one line if that's easier for you, but this kind of helps you see how this adds up then. You've got your x cubed. You got a negative x squared and a negative 7, so that's a negative 8x squared. 7 and 10 gives us 17x, and then the minus 10 at the end. And there's those three binomials multiplied out and simplified there. All right, look at example 3. Example 3, oh, hold on, before we go on to example 3. Solving a quadratic equation. We're going to skip over example 3, actually. Solving a quadratic equation. If you want to solve a quadratic equation, you've kind of got two approaches that you can take, or those are the common two approaches. When you talk about solving a quadratic equation, we're talking about solving something that's in this form. You've got ax squared plus bx plus c. That's your polynomial form for a quadratic expression. Since we're setting it equal to 0, that turns this expression into an equation, because now I have an equal sign in there. So we've got a quadratic equation in that form. It can be solved algebraically in two ways. And so the two ways that we're going to solve this, one is by factoring. So we're going to try to take that polynomial form of that quadratic expression and rewrite it in that factored form for that quadratic expression. So factor the quadratic expression is one method that we can use. The other method that we can use is to use the quadratic formula. And so we'll use the quadratic formula. Hopefully we remember that. If not, we'll refresh our memory here of what the quadratic formula is. We're going to skip ahead to example 4. Example 3 actually is the same quadratic equation here or quadratic expression that they gave us here in example 4. So example 4 says to solve by factoring, and they've given us x squared minus 6x minus 23 is equal to 17. All right, so if we want to factor that, or solve that by factoring, the first thing to do is get the 17 over with the rest of the quadratic expression. So subtract 17 from both sides, and we'll be left with x squared minus 6x. Negative 23 minus 17 sounds like a negative 40, and that's equal to 0. So now we have this polynomial form of this quadratic expression that's set equal to 0. And so if we're going to factor this, I have to come up with two factors that I can multiply together to end up with 0. So the two factors that I'm looking for are two linear factors. I need the first term in each factor here to give me a product of x squared. So the easiest choice here is to choose x times x will give you x squared. And then for the constant part of this, I need two numbers whose product is going to give me a negative 40, but whose sum is going to give me a negative 6. So I'm looking at these other two terms here to help me come up with what's got to go in the last spot here. So I need two numbers whose product is going to give me 40. So there's several factors of 40. 1 and 40, actually we could write these out. Plus or minus 1 and 40, plus or minus 2 and 20, plus or minus 4 and 10, and then plus or minus 5 and 8, right? Those are all the factors of 40. And then you're looking for two of them whose sum would give me a value of negative 6. So it looks like 4 and 10 is going to be the winner in that list here. I need to subtract the 10 and then add the 6 in order to make that happen. Oops, sorry, not 6, 4. I need to get 40, not 60. All right. Subtract the 10, so that way when I have a negative 10 and a positive 4, that'll give me the negative 6 that I need in the middle there. And of course, negative 10 times 4 will give me the negative 40 that I need. So that looks good. And then the way we solve this, whenever you have a product that's set equal to 0, you set each one of those terms equal to 0. So really what you're doing, although many times we don't write down this step like this, and that's fine to skip past this, but just so we're clear on what we're actually doing, you're taking the first factor and setting it equal to 0, and taking the second factor and doing the same thing, setting it equal to 0. And now solve. Adding 10 to this first equation gives me x is equal to 10. That's one solution. Subtracting the 4 over here, x is equal to a negative 4 is my other solution. So those are my two solutions to that quadratic equation. And we found it by factoring. Okay? All right, look at example 5. Example 5 now gives us actually the exact same problem. So that's good because we perhaps know how to solve that problem, but they want you to solve this by using the quadratic formula this time. So exact same problem, but a different technique. So we've got x squared minus the 6x minus the 23 is equal to 17. All right, so use your quadratic formula to solve this. First thing, in order to use quadratic formula, that means you have to have this set equal to 0. So you still have to do the same first step of moving the 17 over to the left side. So subtract 17 will give us a minus 40 over there, and of course now it's equal to 0. And now you're set to use your quadratic formula. And your quadratic formula, maybe I'll remind you of it over here on the right before we write it down here. If you have ax squared plus bx plus c equals 0, then we know that x is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. There's our quadratic formula. So that's what we're going to use here to solve this. So we have x is equal to the opposite of b. b is a negative 6 in the middle there, so the opposite of that is a positive 6. It's plus or minus the square root of. It's the b squared. So b squared, negative 6 squared is going to give me 36, minus 4 times a times c. That's 4 times a is 1, times c is a negative 40. And that's all over 2a, which is going to be just 2. And now we should simplify this. So we have 6 plus or minus 36 plus 160 sounds like 196, the square root of 196. All over 2. And the square root of 196, that turns out to be a nice number there. That's going to be 14, right? Yeah, 14. So this is equal to 6 plus or minus 14 all over 2. And again, keep simplifying until we finally get down to our two numbers there is what I'd like to see. So 6 divided by, well, let's add the numerator together first. I guess you get 6 plus 14 is 20. Divided by 2, that's 10, is one solution. And then do 6 minus 14, that's a negative 8. Divided by 2, that's a negative 4. That's the exact same solution that we just came up with on the previous slide there, just using a different technique, factoring versus the quadratic formula. All right, and that's the end of the first half of this section, section 4-2.